All right, so ladies and gentlemen, as a word of introduction, my name is Rafał Jaczyński. I'm responsible for cybersecurity in Huawei across 28 countries of CE, Nordics, and Central Eastern Europe and Nordics region. And today we'll be, as discussed, talking about cars, but not the cars which drive, but the cars which talk. Now, where did this idea of talking cars actually came from? I believe it is an offspring of human laziness and human aversion to being killed by machines. Laziness is simple, right? Think vacuum cleaner or think elevator. So actually pretty the same desire laid foundations when someone actually started to say that autonomous cars would be a great idea. However, in terms of killing, it's not that simple, right? Because humans don't appreciate, right? It would be a too far a stretch, but actually accept the fact that from time to time we would kill each other if the mood strikes, or there is a good reason, right? But we are very much averse if a machine decides by itself to kill humans, right? So if you have a car accident, it's not making news, right, in the most newspaper. But actually, if autonomous cars hit someone or kill someone, it will surely make the news worldwide and overnight. So it turned out that it is very difficult to make fully autonomously driving cars that are better much better than humans in terms of safety. It is not because humans are excellent drivers. On the contrary, humans are very bad drivers, pathetic drivers. Actually, you could put the current autonomous driving technology pretty much on road right away, and probably the fatality rate would not increase, right? But it turned out that there are limits in terms of what the onboard systems that the autonomous cars are carrying, like radar, LiDAR, or cameras, can do, right? So actually, this desire to not be killed by machines has actually started a silent parallel revolution. Another one. We are not talking about cars, but we are talking about actually digitalizing roadside infrastructure and connecting the cars to both the infrastructure and the network. It goes under the umbrella of V2X, vehicle to everything concept, which further slips into vehicle to infrastructure, so it's roadside infrastructure, vehicle to vehicle, so car talking to each other, vehicle to pedestrians or cyclists, so the vulnerable road users, and vehicle to network in order to enrich the awareness of the car with data which can be provided by networks such as internet. Not only for awareness of the car itself, but also for entertainment for people. So, as I mentioned, indeed, safety was the major driver, and actually it shows in numbers. It is agreed that roughly 90% of car incidents are caused by human error. So actually, it creates an addressable space for something really better than human drivers. And as I said, with onboard electronics, with all the LiDARs, etc., you can shave roughly 60% of this number. You can hope to shave 60% of this number. To fight for another 30 to 36%, you actually need to extend the car ability to see beyond the line of sight. So, for instance, to see beyond beyond the corner, beyond the road curve, see beyond more than the current tools give visibility. Both in terms of range and in terms of obstacles. You can figure it out on the very, very classic example of the junction, right? When you are approaching a junction with the right of way, and someone is actually coming from your right, not exactly respecting your right of way, right? And you collide. If only those cars were able to see each other and communicate with each other, that they are in the same place at the same time, coming at each other at speed, this simple capability could allow to avoid roughly 80% of accidents in such cases. Think also about smartphones. There are, like 500 million smartphone users in European Union, give or take. If the cars were able to communicate with these smartphones to give a heads up that actually something very, very heavy and very fast is coming, and would you just raise your head, please? Think about your kids, right? you know how they actually may cross the road nowadays looking at the smartphone. So actually the smartphone makes it a perfect choice for actually raising the alarm. But life can be also translated into money. The cause of the accidents, of car accidents in European Union, is estimated to roughly 80 billion euro annually. And in different parts of the world, it actually translates into 1 to 3 percent taken from country growth product. So this is money on the table, not only in saving the fatality rate, in saving the car accident rate, but also in optimizing the traffic itself, saving on energy, whether that's fuel or electricity. Just imagine that the only solution currently we have as a response in cities to reduce the fatality rate on the roads is actually decrease speed, which creates traffic jams, right? And those traffic jams also have a price tag next to it, again, in the range of 100 million euro, 80 to 100 million euro annually, right? So actually, this is the only solution we have. But if only our cars were able to constantly communicate with the traffic light system, that would tell them what speed they should automatically take to actually make the traffic flow smoothly. The research showed that we could save as much as 15% of energy, because, and at the same time, increase the average transfer speed across cities. So less traffic jam and more satisfaction. It will be also very likely that those autonomous cars will be simply much safer in driving that cars driven by humans, because it will extend the awareness beyond the line of sight. So it will be easier to detect obstacles beyond curves, etc., or in bad weather, right? And at the same time, the latency which can be delivered at the end of the day doesn't actually slow down the decision. The normal time for an average person to actually hit a brake when an obstacle is seen, it's around half a second. The best Formula One drivers would probably reach 200 milliseconds, right? So actually, the added latency introduced by V2X can be as low as 20 milliseconds in such circumstances if the distance is lower, or actually maximum 50 milliseconds, which doesn't actually make that much difference. And because the car reacts autonomously, so actually bypasses our old and tired brains, the overall elapsed time is actually promising to be much better than it currently is. Okay, so right, one more comment. However, those benefits are interesting. It is not an easy task to make a business case for V2X connectivity. The reason is that all those benefits kick in after a certain scale is reached. If you have one road in the city with roadside infrastructures and traffic lights able to communicate with vehicles only on this road, right? And you have two vehicles in the whole city able to talk to each other. I mean, it's obvious that you won't reap this benefits. So actually, what you are looking is a mass scale which is necessary to achieve the result, and actually it slows down the investment, because I mean, weighing huge investment versus potential promises is never a good a simple decision to be made either by businesses or countries. Okay, but assuming that we have money, and we want to go with it. What technical choices do we have? We have two choices currently, basically, for car to cars and car to infrastructure connectivity. One is based on good old Wi-Fi. It is called, in this use case, dedicated short range communication, so DSRC. Another option is use the first two layers of cellular protocols, whether that's 4G or 5G, to communicate as well between cars and the infrastructure. And the choice is also very simple. In terms of future proofing, cellular version wins in pretty much each and every scenario, whether we are talking about a city, whether we are talking about a country, whether not a junction or a junction. Even the 4G connectivity, so 4G protocol, seems to be better in terms of range, reliability, and latency from Wi-Fi. However, if you'd like to have something on the road right now, Wi-Fi is the easiest choice, right? Because the number of cars with Wi-Fi V2X is currently higher than with cellular connectivity. Actually, the first car with a connected car, a fully connected car, was put on the road like 5 years ago in 2016. It was a Toyota with General Motors for following the suit. So actually, especially in US, this Wi-Fi connectivity is currently not a dream. It's becoming a reality. But in terms of future proofing, I would go with the cellular option. Now, why do these figures like latency, reliability matter? The simple answer is that they translate into specific use cases. If you have a ping of 100 milliseconds, it is good enough for broadcasting some information, right? So there is some congestion, some obstacles or roadworks further down the road. But actually, if you think about applying brakes, about directing the car, it is not good, it's not enough. The really useful use cases start from 25 milliseconds end-to-end latency. We are talking about platooning, so the tracks can be put in a row and actually drive wherever they want, keeping order and distance, which is especially very important at Polish motorways. I would say it. I just hate two tracks overtaking each other for the next 5 minutes. So actually, the notion of them being controlled by something else than a human brain is really appealing. You can talk about short distance platoonings when you put cars and trucks closer to each other, also in traffic jams, but also at speed. There is a interesting use case for remote driving, which is not intuitive, right? But actually, because we are talking mostly about autonomous cars, but it is a very interesting case which is currently used in 5G deployments, especially in areas where humans don't like to go. So think about remote driving of all these machines in mines, for instance. It is too dangerous sometimes for people, so let's remotely steer the machine. But for that, you need really a very low latency. There is also an interesting use case called sensor sharing, right? Because for the time, for the first, in the future to come, not all of the cars will be connected, right? So what do we do with cars which refuse talking to others on the road? This is exactly something called sensor sharing. So for instance, if a connected car approaching a junction detects that there is an object, moving object, a car, which is not really talkative, this connected car can pass this information or broadcast this information to other connected cars in the vicinity. So actually, it is sort of your other cars are using your eyes, and you are sharing the information you have seen. Now, as you can see, the use cases end at 5 milliseconds, but there are also numbers like 1 millisecond on the picture, at which point I need to make a comment, because I'm sure you have seen the promise of 1 millisecond latency in 5G, right? it will be extremely quick. Now, the good thing is that on this conference, pretty much everyone is reasonably good at maths and physics. And we probably remember for the high school and future experience that even in 5G, the information won't be able to travel faster than the speed of light. If we make a simple calculation, what would need to be maximum distance between, say, a client and the server, so that the end-to-end latency reaches 1 millisecond? We are talking about 100 kilometers, 140 kilometers maximum. Now, it somehow contradicts the concept of mobility, right? Because I don't see as a good offer to tell the cars to actually go in circles pretty much around the applications, only to make sure that they actually fulfill the latency requirements. So something is going to give. And something is actually passing information that is not correct. And it can be, the default can be either on the side of marketing or on the side of network itself. And it's really a bit of both, right? Because if you think about 5G networks nowadays, it will be an evolution. So the network for the years to come will consist of simply new base stations connected to the old core. And the new base stations, yes, they will use the different coding, the different protocols, they will use slightly different frequencies, but in terms of latency, nothing really changes. So we'll have you will have an air interface connected then through a transport network to the core with a gateway which will connect the network through possibly internet or some other network to your server, application server, right? And if you calculate the timing, there is no specific reason why it should be faster, right? You're ending up around 40 to 50 milliseconds, and it's not good enough for really interactive automotive application. So this architecture will need to change, it will need to shift. And there will be two important shifts. One will happen in the very air interface, right? Because you need to go with latency there. And the second shift will happen in the network, right? Because as we said, you cannot expect to people to go around your applications. So what you need to do is move your applications closer to the users and make them follow the users somehow. And enter edge computing. This is a concept which uses a really distributed cloud environment, which is not installed at the core of the central part of the network as it is currently, but it's still installed in the core of network, but closer to the edge, closer to where base stations are. And if you do that right for applications that are able to communicate with vehicles through this edge computing platforms, you will likely reach the latency at the level of 5 milliseconds, which is really realistic and good enough for most, if not all, automotive applications. So the question is, since we are at Oh My Hack, is this whole thing hackable? And numbers say yes. I mean, overall, automotive industry or ecosystem is very hackable. You can dig out some numbers showing that over the last 9 or 10 years, the number of successful attacks in the ecosystem, so both on cars and manufacturer applications, etc., has rose 7-fold. Even if you take it with a bit of salt, actually this growth is exponential. Also, majority of attacks, in the range of 80% nowadays, they are remote attacks. And yes, many of them are just attacks on the keyless entry systems to actually get your hands on the vehicle without pretensions to actually do anything interesting. But still, it seems that the promise the manufacturers once made, because there was a simple excuse, right? Yes, you showed me that my car is hackable, but actually we only focus only you had to connect to it physically, right? So actually we are focusing on making the car secure from outside, right? So actually, so no remote access is possible. As you can see, this promise is not clearly being delivered, and there are good technical reasons that it will be actually going worse. But how it looks in practice. First of all, let's have a look how the car looks in practice, right? It's no longer that simple as on the picture, because the model car nowadays are nothing less like as networks on wheels. So we'll have a bunch, and a bunch, I'm saying around, for instance, 100 of microcomputers called electronic control units. Each is doing some in-car functions like controlling brakes or controlling an entertainment system or air conditioning, navigation, steering, etc., etc. And these boxes communicate through a network which from a security perspective is really nothing more than a wire. The whole security of this idea hinges on the assumption that the ECUs will behave. So only reasonable and legitimate messages will be sent to the bus, which is using as a legacy usually the CAN protocol. We will probably hear more or the available protocols tomorrow from the guys from Division Zero. And the second and third assumption is that the receiving ECUs, which are just listening to the bus, pick up only the messages which are relevant to them. And from this point on, follow only the logic which was imprinted in them. So actually, if the system works as designed, it works fine, but actually it has virtually zero resistance in reality to external manipulation. And still, you could say that, okay, this is a, a hackable box, but actually, since you are, sitting on this very box usually and going at speed, it doesn't give you a motivation to actually play with it, right? Because and the things can get haywire, right? So actually, it was again another defense from manufacturers. Now, what unfortunately happened over time is the car got connected. So you have one of the ECUs, which is bridging the internal network and connecting it to a telematics control unit, which is further providing usually wireless interfaces to the whole system, right? It interfaces with V2X infrastructure. It interfaces with Internet of Things infrastructures. It interfaces with the services provided by manufacturers, by suppliers, by service providers. And pretty much the only defense car manufacturers are officially using is that, all right, but this box which handles the communication doesn't have a direct access to the CAN bus, right? So this is the interesting place where interesting things happen. But what we have a situation is the situation that, this is a guy who knows the guy, right? I mean, you don't always need to have direct access to the bus if you can communicate with a module that does, and this module turns out to be flashable, for instance, you can force this module to actually do a job for you, right? So it's actually in the security by design this concept is really lacking. Apart from this connectivity options, you have also some physical ports, of course, like OBD2, which is a diagnostic port. It used to be physical, but is again no longer the case. Because aftermarket provides very helpful and useful dongles, which actually allows you to connect to the physical port of the vehicle and provide a remote access to the dongle, so that you can not only read, but in many cases also send the CAN messages to the bus. And then the security, as I said, pretty much hinges on how would the system react, whether these messages would be picked, whether it would be easy to fool the design, whether these other ECUs are again flashable, right? But actually is by chaining vulnerabilities, you will have access. And this is exactly what happened in reality. I think the most interesting, because the biggest also, car security research was done by Charlie Miller and Chris Velasek. And they got famous at some point because they hacked a Jeep. They took control over its driving, and they demonstrated that they can steer the Jeep remotely, not actually sitting in it, not even being in proximity of it, but actually steering it over the cellular network. But they actually went from there with a research that consisted of 20 different cars of different manufacturers, which allowed to draw some more general conclusion on the state of affairs. And the state is not pretty. If you look at the results of the research, you can divide the cars pretty much in 4 groups. The smallest group were, just douchebags, very old cars. Even if they had some electronics, the electronics playing with this electronic wasn't fun. I mean, how funny it gets, manipulating the wipers, for instance. It gets pretty old very quickly. But the majority of cars can be divided into 3 buckets. The cars which had serious security issues at ECU level. So for instance, the ECUs didn't have a secure boot. They were flashable, which whether that was difficult or not is a different story, but they were flashable. The cars which had a pretty lame network design, because for instance the bus providing services to the entertainment and multimedia system was not separated in any way from the bus used for steering the dynamics of the car. And the biggest group was actually cars which had issues in both departments. Additionally, they actually came up with some general observations, which I think might be considered a sort of Moore law for car automotive cybersecurity, unless we do something about it. The first was that the newer the car, the more complex it was, right? So actually, both in terms of the number of computers, of ECUs used, and also in the number of networks that was embedded in the cars. There was also increasing variance of topologies. So actually, it didn't look like manufacturers are trying to come up with a unified secure design. No, actually, there were variations and differences in network topologies and in the car topologies, even within the same brand. The second law is that the newer the car, the more connected it is. And we are not only talking about the connectivity at infrastructure level, we are talking also about the connectivity in user plane. So increasingly, we are seeing web browsers and in-car apps in the car. What it gives you, I mean, I think I shouldn't explain exactly what opportunities it presents. The third law is that the impact is also increasing, because the newer the car, the more cyber steerable it is, right? If with the old ones, yeah, you can play with the wipers, but actually the newer the car is, you can take control of it, park it remotely, summon it. You can actually pretty much drive it, right? So actually, this is the third trend, which is worrying, and it is especially worrying that you could expect that the automotive industry took notice after this kind of research. As I said, it was 20 cars of different manufacturers, but it doesn't seem so, because some new report from Ponemon from 2019 shows clearly that over 50 of stakeholders in the ecosystem, whether that's manufacturers of cars or sub-suppliers, do not care about security in the design, or doesn't care in the vulnerabilities in the development and testing phase at all. And we are talking about 2019 people. Now, the only good news potentially from this research, which was good news until comparatively recently, is that, honestly, car hacking was very expensive. This very research was sponsored by DARPA. It's to a degree went without saying that if you want to hack a car, you need to own that. So they bought the Jeep, they bought other cars. They actually spent, if I'm not mistaken, $30,000 on tools alone to understand how it all works and reverse engineers the different ECUs, right? So it's not exactly a game for script kiddies. Borrowing your dad's car for weekend won't cut it as well, right? Because you probably would like to return it in a good condition. So actually, the barrier of entry was comparatively high from time and money perspective. But if something is telling me that again, tomorrow's presentation from our friends from Singapore will show that you can actually get away without owning a car to hack it. So this is exactly where things are getting interesting, especially for the criminals, right? Because I mean, you can I mean, no, I don't think majority of use cases will be taking the control over someone's car to actually drive it off the road and report a successful assassination. I actually think, and the research from Charlie and Chris confirms that it was actually easier to get access to uh, all Jeeps rather than a particular selected Jeep, right? So think about ransomware, and in the B2C format, as a service to customers, I've been thinking about a very simple scheme. I call it pay as you go. So actually, when you sit in the morning in your car, your head unit displays a welcoming message that actually launching the car would require a very moderate or very small payment in Bitcoin, right? So actually, there is space for making business on that as well. Other things which happened recently also prove that the automotive industry is not yet up to speed, I would say. Tencent in Lab bought themselves a new Lexus NX 300. And they had a go at it. And what happened was entirely predictable. They managed to find a chain of vulnerabilities which allowed them to transverse from wireless access initially from Bluetooth and Wi-Fi to the bus of the car at the end, and they managed to launch certain diagnostic functions and diagnostic primitives of the car. And I really like this quote. As a result, the car performed some unexpected physical actions. So as you can see, it wasn't just wipers. Now, what is important to understand is that we are not talking about IT environment any longer, right? You are familiar with the concept of patching Tuesday, right, which is a monthly routine from Microsoft. If you look at the timing of the patching in this case, well, you know, these vulnerabilities were reported back in August 2019 and discovered in August and reported later in October that year. To Toyota. The mitigation plans, technical mitigation plans, were provided to the researchers in March 2020. But still, there is no detailed report on the findings. And the reason for that is that these vulnerabilities are still not patched. So we are talking about 2 years and counting. And if you are into operational technology, into not purely IT infrastructure, but into infrastructure which is used in manufacturing, in power grids, it's not news for you. But the bad news is that it applies to this long life cycle applies also to car manufacturers. Just imagine what could happen if these vulnerabilities were discovered not by researchers following responsible disclosure, but actually by someone who didn't, or criminals. The window of opportunity is 2 years and counting. You could also argue that getting access to a car through Bluetooth or Wi-Fi is not that sexy, right? Because you would have a preference to hack vehicles from your own couch, not actually being seen nowhere near. But the recent experiment coming from Ralph Philip Weinman and Benedikt Schmotzle actually pointed many people into the right direction, that a hackable car and a drone is really a match made in heaven. And they managed to, well, the hack itself was not extremely dangerous. They couldn't take control over Tesla drivability, but they could access different features of cars, open doors, and manipulate all sorts of features on board. But what's most important, the hack was wormable. So they were able to reprogram the telematics Unix, providing talking to them through Wi-Fi, into a hotspot that would distribute the modified firmware further to other cars. It may be not a usual sight to see hundreds of Teslas nearby, but actually, if you think about manufacturer parking lot with hundreds or even thousands of cars ready to be shipped, a hackable Wi-Fi control and a drone in your hand, this is a huge opportunity for business-to-business type of ransomware. So actually, you are looking to both something for consumers and something for businesses as well. So how do I look at the whole issue from the point of view of the whole system, right? Because I wouldn't like to focus too much on individual elements. I think the system should work as a whole in a secure way. It is a picture we have seen now and again. You have a bunch, an increasing number of vulnerable clients, which are connected to services or applications which have never been secure in the history of mankind. And this connectivity happens over a network, which is actually quite secure by design, because cellular networks are the type of networks where a lot of effort is put into making it secure at the standards level, right? It's not bulletproof. It doesn't provide end-to-end confidentiality, etc., etc. But actually, following a risk analysis, a lot of effort is done at the standard level. So actually, the result is you have as insecure clients potentially connected to insecure applications or platforms over a potentially secure network. But the network will be secure only if the stakeholders around the network, so for instance, manufacturers and first of all, operators, do their job correctly, because the devil is in the details. We mentioned very briefly the edge computing concept, which is a distributed cloud sitting closer to the base stations. Well, cloud for many of you is a thing which is obvious, right? It is all about segregation, separation. This cloud in a telco environment, in a telco network, will have different connectivity depending on the business model used. For instance, if the infrastructure will be provided by an operator, and it will be controlled in a slightly different way. If it's going to be an external cloud provider, it will also need to interface with the core network of the operator by using different interfaces. And this means that the services from the core network of the 5G network will be exposed to third parties. Now, if you go into a lower level of details, of course, this cloud, this edge computing cloud, will be all about segregation, because you will have applications and platforms coming from all sorts of sites, from operators, from third-party providers, from automotive manufacturers, in the case of V2X, from the city, etc. So the key is segregation and isolation. And everyone familiar with the cloud is actually bread and butter for any cloud security expert. The question is whether telco providers are really cloud security experts, right? Because at the end of the day, it is the telco operator which is supposed to keep this whole infrastructure in order and secure. The good news is that previously, the telco security was a bit security through obscurity. Now, since we are talking increasingly about IP, we are talking about cloud, there is a more accessible pool of experts to help the operators out with configuring and keeping the environment at bay. But whether it happens is actually something we need to see. If it happens, we will be able to comfortably focus on improving the client side, so in-car security, and the security of platforms and applications where the data is aggregated and when the business logic is executed. Coming to an end, a bit about privacy in a car. I mean, okay, probably many of you had a situation in the past, probably a past long gone, but in the past where you really needed that bit of privacy in your car. And you know that it is not easy to get. And it's even more difficult with connected cars because they are just, a sensor driving around. You are talking about the order of magnitude of 20, 25 gigabytes of data processed by the car daily. The processing power of this thing is more than like 20 PCs, right? So it's not no longer a dumb small device, not able to actually do anything interesting. And the data which it collects is coming from sensors, from radar, from LiDAR. It's coming from video, so you have biometrics in it. It is also coming from accidents, so you have sensitive health data in it. There are some challenges with broadcasting location. The system, by standard, has some features which prevent the location of vehicles to be tracked. But it is not bulletproof, right? It is reliance on the implementation of the standards, and it relies on the platform itself. There is also a traditional challenge of compromise between mission critical components and crypto, right? When you have a car driving at speed and the crypto does present overhead. So for instance, the time of requirement, a temporary certificate for the car to access services would double with the crypto primitives used. There is also an issue of machine learning. The cars are increasingly using artificial intelligence, but actually to make the data private, you would need to train the models on anonymized visual data, because all these guys walking on the streets, they don't have even a chance to be informed that something is collecting their private personal data. The PKI, which is standardized, is a bit sophisticated because to prevent privacy, you have actually two types of certification authorities. One of them is supplying pseudonym. One is tied to identity, and the second is supplying pseudonym certificates at a rate of 60 to 100 per week, right? So if you multiply it by the number of vehicles on the road going forward, you have some performance issue. And of course, there is responsibility. Who is actually responsible for making it happen? Is it the network operator? Is it the car manufacturers? Is it the vendor, right? So this is not yet done. And as a summary, just a heads up in terms of what in-vehicle data is kept in the vehicle. U.S. Customs and Border Protection has made recently a very interesting purchase of a software which is normally a type of forensic tool for getting access to data. In this particular case, car data. I encourage you to deep dive through what data is being collected, what would be collected, also to understand the level of details and the scope of data that is processed by a car. Because the scope is not only about the car dynamics, it is most of all about who is driving that car. And the level of detail is at which locations the vehicle lights were switched turned on and which door were open. There is also, I think, an issue of how this information can be used by stakeholders, because I really loved the selling tongue slips in the marketing materials of the company, because they advertise this tool as a forensics tool, right? Helpful for diagnosing car accidents. But when they talk about what happened, right? Diagnosing what happened, they are talking about identifying patterns of life. when they are talking about telling where it occurred, they are talking about not what happened in the past, they are talking about future plans of individual involved. And in terms of tracking those individuals who were potentially involved in an accident, it is not really close and related to the driver. They are talking about determining who was present and aware of key information during an incident. So actually, pretty much anyone which did connect to the car system from the phone, for instance, or pretty much anyone who was visible through the car sensor. So actually, loads of data, goldmine of data, questionable security here from history, uncertain questionable security at the application level, connected through a reasonably secure network if everything goes well, if operators and network providers do their job correctly. So thank you. We made it for the whole 45 minutes. I wasn't certain in my case today. If you have any questions, happy to answer them.